Okay, today we're going to do Unit 7, or Unit 4, Notes number 7, which is our linear application. So what we want to go over first is our slope-intercept form. Slope-intercept is our y equals mx plus b, where m is our slope, because it's the number next to our x, and b is our y-intercept. Okay, so let's go through our first word problem. It says Mrs. Mariani starts the year with 200 Jolly Ranchers. She gives out 20 every week, and this can be described as the function f of x equals negative 20x plus 200, where f of x is the total number of Jolly Ranchers, and x is the number of weeks. Okay, let's read through this again. So Mrs. Mariani, she starts the year with 200 Jolly Ranchers, and she gives away 20 every week. Okay, they give us our function, which is f of x equals negative 20x plus 200. Just remember, f of x and y are the same thing. F of x is our total number of Jolly Ranchers, and x is the number of weeks. So it says, what is our x and what is our y? So it says let x equals number of week. It says x equals number of weeks, so we're going to let x equal number of weeks. And then f of x we said is the same as y, and this equals the total number, or total Jolly Ranchers. Okay, so now let's go down and we're going to fill out the table and answer the following questions. So we have our x, which is our number of weeks, and our y is our number of Jolly Ranchers. So let's just start with 0. At 0 weeks, we haven't given any Jolly Ranchers, so we have 0, 200. For 1 week, we've given out 20, so we have to subtract 20, so it'd be 180. After 2 weeks, we give out another 20, so we have to subtract 20 again. 3 weeks, we give out 20 again, so we have to subtract. After 4 weeks, we give out 20 again, so we subtract 20. So, how many Jolly Ranchers did Mrs. Mariani have to start with? She had 200 Jolly Ranchers. How long will it take to run out of Jolly Ranchers? So if we keep going, so at 5 weeks, she'll have 100. So what you could do is you could just keep extending your table. So at 5 weeks, she'd have 100. 6 weeks, she'd have 80. 7 weeks, 60. 8 weeks, 40. 9 weeks, 20. And at 10 weeks, she would have 0 Jolly Ranchers. So it would take her 10 weeks. Does this linear function have a different domain than the parent function? So if you guys remember, our domain is our x values. So think, okay, what x values does this graph fall in between? Well, it started at 0 and it ended at 10. So if you guys remember, our parent function, it's always all real numbers. But this one, our x values started at a 0 and it ended at 10. So this does have a different domain. So we can say our domain, and you can say it is between 0 and 10. Or you can write it out in a different format. This is where we do 0 is less than or equal to x, which is less than or equal to 10. This basically means our x values are between 0 and 10. So now we have to think, does this linear function have a different range of y values than the parent function? So y values, it starts at 200 and it ends at 0. So our parent function is all real numbers. because our graph goes on forever. This one, it doesn't. It starts at 0. It starts at 200, ends at 0. So yes, it also has a different. And this is between, oops, let me spell it between right. 0 and 200. So another way we can write this is by putting 0 is less than or equal to y, which is less than or equal to 200. And you guys, our inequality signs for our domains, or for these domains for our word problems, are always going to be the same. Because it's basically saying y is less than or equal to 200, but it's greater than or equal to 0. So we're in between 0 and 200. It says create a graph to represent the given information. Okay. So we know, given this information, our x-intercept is where y equals 0. So 10, 0 is our our x-intercept. And then 0, 200 is our y-intercept. So graphing this, we already know our x value is number of weeks. We're going to go up by ones because we only need to go up to 10. And then our y value is number of Jolly Ranchers. And this one, we need to get up to 200. So I say let's go up by 20s. And if you guys, one way to help you know what value you need to go up by, always use your slope. Our slope on this one is negative 20. So that's what you should probably go up by on your y-axis. It'll help you with graphing it easier. So 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260, 280. We're going to stop right there. Okay, now for graphing it, we know our y-intercept is 0, 200. So we're going to plot a point at 0, 200. Then our y-intercept is 0, or is 10, 0. So we're going to plot our other point there. And then we're just going to draw a line in between these 2 points. And that is my graph. So one thing I want you guys to get from this, number 1, how to graph it and how to label your graph. 2, you have to know your domain and range. So our domain is our x values. So where does this graph fall in between on our x values? This one, the line was between 0 and 10. Our y, which are domain's values, the line was between 0 and 200. This line is not going to continue on because once I'm out of Jolly Ranchers, I'm out of Jolly Ranchers. So keep that in mind. Okay, let's go to the next page. We have 2 more examples to do. Our first one says Luca has 20 books on her bookshelf. So that's probably going to be important. She has 20 books on her bookshelf. She reads 2 books every week. This can be represented by the function f of x equals negative 2x plus 20, where f of x is the total number of books after x number of weeks. So it gives us our x and our y. Because our f of x is our total number of books, and then our x is the number of weeks. So let's fill those in. So x is number of weeks. And then f of x is the same as y, and f of x is our total amount of books. Okay. Now, the next thing it wants us to do is graph this. So if you guys remember, we have to label our axis. X is number of weeks, and Y is total amount of books. So for our x-axis, we're going to put number of books, or number of weeks, and we're going to go up by 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then our Y is our total amount of books. And you're like, Mrs. Gilbert, how do I know what to go up by on my Y-axis? Let me get this written. We're going to always go up by our slope. So if you look at the equation, which they gave you, your slope is -2. So we're going to go up by 2's each time. X's, you can always go up by 1's. 6, 7, 8. Oh, goodness, if I can count by 2's. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay, we're just going to go up there. So next we have to, we're going to use this equation to plot it. Now, I'm going to tell you this. If you need to put this into your calculator to help you, you are more than welcome to do that. But we know our y-intercept is 20. So that's going to be the first point I plot, is I'm going to plot a point at 20 on my y-axis. Now my slope is -2. So since he's reading 2 books every week, I'm going to go down 2 books over 1 week. Down 2 books over 1 week. And I'm going to keep going down in the same pattern. That is why I'm saying if you go up by your slope, you'll be able to go down by the number of just 1 box each time. Okay, draw a line in between your points. Actually, this is just a segment because once I'm out of books, I'm out of books. Luca can't read anymore. Okay. Now, give a reasonable domain. So our domain, if you guys remember, is your x values. So what x values does this fall in between? It starts at 0, because that's for my y-intercept, and then it stops at 10. So your x values are between 0 and 10. You can also write this as 0 is less than or equal to x, which is less than or equal to 10. You do it either way. Domain. Oh, this one's supposed to be range, you guys. Sorry. Range is your y values. So this one, your y values fall between 0 and it goes up to 20, and then it stops. So you could state y values are between 0 and 20. You could also write this 0 is less than or equal to y, which is less than or equal to 20. Either one would be okay. Now it says state the y-intercept, explain what it represents. Y-intercept on this graph is 20. So our y-intercept is 0, 20. What does this mean? This means at 0 weeks, Luca has 20 books. Because if you guys remember, our x is our number of weeks, and our y is our books. So we're basically just putting that into words. Okay, let me know if you guys have any questions on that. We're going to go down to the last one. Okay. So Connor has $800 in his bank account. That's important information probably. It's $800 in his bank account. Every month he spends $50. Connor is not adding any money to his account at this point in time. This can be represented by the function f of x equals, this should be negative 50 actually, guys, because he's taking it out. Negative 50 plus 200, or plus 800, geez. F of x is the amount of money in Connor's account after X number of months. So we're going to let X's number of months, and then F of X or Y is the amount in account. Now I'm going to add something onto this one. So we're going to state that he stops withdrawing money, or he stops spending money when he has $200. Okay, so we're going to graph this. X is our number of months. So we have 0. We're going to go up by ones on our x-axis. And then our y is amount of money. And like I said, we're going to go up by our y-intercept. Our y-intercept is 50. So we're going to go up by 50 each time. Or by our slope, sorry. So 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600, well, it looks like we're going to have to add another line to get to 800. That's okay. Okay, so our y-intercept we know is 800 because that is where, right here, it tells us our y-intercept is 800. So we're going to plot that point. Then he's taking out $50 every month. So we're going to go down by $50 each month. Now, I told you that at $200 he stops taking out. So this graph is going to stop. So whenever we're at this 200 mark, the graph is going to stop. So keep that in mind. So it looks like we're going to stop right here. He's not going to take any more money, and he's not going to spend any more money at that point. So we're going to graph this line, and it's going to stop at the 200 mark. Now, give a reasonable domain for this situation. So our domain, if you guys remember, is your x values. So these x values, it falls in between 0, and then the graph stops right here at 12. It doesn't keep going. So you can say x values are between 0 and 12. Or you can write it, is it 12 right? Yeah. 0 is less than or equal to x, which is less than or equal to 12. Okay, let's go down to this one should be range, you guys. I'm sorry. And I may already have it fixed on your notes. So our range is our y values. So what do our y values fall in between? Looks like it starts at 800 and it stops at 200. So your y values are between 200 and 800. Another way you can write this is 200 is less than or equal to y, which is less than or equal to 800. As long as you're telling me my y values are in between those two numbers, I'm okay with it. Okay, last one. What is our y-intercept? Our y-intercept is 0, 800. What does this mean? If you guys remember our x, our y, our x is months, and our y is money. So we can state this as at 0 months, he has $800. Okay, let me know if you guys have any questions on this, and you guys can get started on your homework. I know this was a long set of notes, so you guys did a great job.